This will be lesson 5 of chapter 7, and in this lesson we'll talk about two sets of compounds that mix the idea of ionic and covalent together. The first one of these is something called hydrates. Now, a hydrate has in its formula a water molecule. In fact, the prefix hydra refers to water. So this will be ionic compounds that have water in their formula. Many ionic compounds can actually absorb water and incorporate it into their formula. Now, the compound won't be liquid, it will still be a solid. In fact, you won't be able to see the water. The water is stuck inside the ionic compound. In fact, it fits between the ions, the positive and the negative ions. So the water, however, is not permanently in there. It's not a strong chemical bond, and heating will remove the water. You have an example here of a compound that's hydrated and then dehydrated. So when it's hydrated, the color is blue, and then when you heat it up, if you put the Bunsen burner underneath it, for example, for a good few minutes, you will dehydrate it and it becomes white. Now, not all compounds go from one color to the other. Here you can clearly see that this is a neat example because this one looks like it has water in it because it's blue, and then once you drive the water off, it becomes white. Many compounds won't change color. They'll just remain white. But some will, which is neat visually to see this concept. What we'll do is we'll teach you how to name these compounds. So the rules for naming them actually won't be much more than what we've already learned. The first portion of it, the ionic portion of the compound, is the same as our ionic rules, which recall meant that you have to name first the cation and then the anion. So, and then the second portion of these hydrates would be the water portion. And the water portion, you would use prefixes from your covalent naming. So the di, the tri, the tetra, these prefixes that we learned about. So essentially, you're combining the ionic and the covalent portion together. Because water, remember, is a covalent compound. So we have to use, you can say, covalent rules for it. So here's the big example, and then we'll try a bunch of examples together. So here we have BaCl2 dot 2H2O. Now this dot right here actually means that the water is bonded to the barium chloride. And there are actually 2 water molecules for every one of these ionic compounds. So this dot means that it is not strongly chemically bonded. You can say it's bonded, but not as strong. Not as strong as you would, for example, not as strong as the barium and the chlorides are bonded, or the H and the O. So this is like a weak bond, you can say. That's why you can drive it off by heating it. So the way to name it is you first write the name of the ionic compound, in this case barium. Remember, the first ion does not change. The second ion changes to ide, so chlorine becomes chloride. And then for water, you would say hydrate. And then you would indicate with prefixes how many waters you have. In this case, we have 2, which is dihydrate. There it is. And by the way, you can rehydrate it. So here's an example of adding water back and making the hydrated compound. So this right here is the hydrate, and this right here is the normal ionic compound without the hydrate. Many times, if you've ever purchased something brand new, you would find these little packets in the purchased item, especially if it's a clothing item, and these are called desiccants. You can kind of see the word desiccant. And what they do is they remove moisture or water from the product. And this is because if moisture gets in the product, that will eventually start going bad. Bacteria can start growing, and especially if it's a leather, it'll actually get ruined. So the desiccant is put in there. The desiccant is simply a hydrate, or a compound that becomes a hydrate that can absorb water. So actually it goes through the walls of this container, and the water is absorbed inside. And this gets, you can say, fuller and fuller. So it gains mass. So these compounds are actually used, commercially used, and we will use them in chemistry. So let's show you some examples. Why not we try a few of these examples? Let's do 2 going from the formula to the name, and 2 going from the name to the formula. So the first one is K2S.5H2O. K2S is named using our ionic rules, which names K as potassium. S is sulfur, which becomes sulfide, potassium sulfide. And then the hydrate, 5, the prefix for 5 is, correct, penta. And then hydrate. So the whole compound is named potassium sulfide pentahydrate. Very fun to say. The second one here is CaSO4.2H2O. So the Ca is simply calcium. Now the SO4 is a polyatomic ion. Remember, this is sulfate. So the polyatomic ions do not change their endings. You simply keep it as sulfate. So calcium sulfate. And then we have 2 waters, which the prefix for 2 again is di. So dihydrate. Calcium sulfate, dihydrate. Not too bad. Okay, let's try the next one. Next one is magnesium nitrate hexahydrate. So we'll have to write the formula for this one. It's made from magnesium and, in blue, and nitrate. So remember, because these are ionics, you have to consider their charges. They're ions. You have to balance their charges. So magnesium and nitrate. Magnesium has a charge of +2 from the periodic table. Nitrate is a polyatomic ion with a -1 charge. So because you have nitrates -1, you need 2 nitrates. We'll need another nitrate with a -1 charge. So my formula would look like this. Mg parentheses NO3 parentheses 2. And then I have hexahydrate. So I will need 6 waters. So we'll put dot 6 H2O. Simple as that. Let's do the last one. The last one involves tin. Now tin has a Roman numeral because, remember, the Roman numerals belong to the D block. Now if you take a look, tin actually does not come from the D block, but it is one of the exceptions to the rule. Most of the P block ions have only one type, one possible ion. Tin has 2. It could be +2 or +4. So one of the slides previous we talked about this exception. So remember that this 2 means the charge, and tin's symbol is Sn, strangely, stannum from the Latin, and then it has a +2 charge. Chloride is just Cl with a -1 charge. So again, we need 2 chlorines for every tin. Let's do SnCl2. Trihydrate, the prefix tri means 3, so we have 3 waters. Not too bad. If you know your ionic naming rules, this is pretty simple. It's really reviewing the ionic naming rules. All right? So hopefully this makes sense. Go ahead and try a few on your own. I've got 4 for you to try. And then we'll practice some more at home or in class. This concludes Lesson 5.